Hey guys, how you going? Just want to talk you through some aspects of um, pentagons, octagons that you might want to consider when you're doing your mathematical investigations. So these shapes are a bit more difficult to calculate the surface area for when we're doing our measurement DI. So just want to make sure that you're not missing anything specific, okay? So first of all, I'm going to look at a hexagon. So that's your six-sided shape. Now, what I'm talking about for this one is also going to apply to pentagons, also going to apply to octagons. Okay. So what most of us have been doing is making the hexagon a regular hexagon. So what that means is every side is going to be the same in terms of its length. Now, this is probably the best way to go. It's just the easiest way to do it. So I definitely recommend doing that. So let's just say each side is going to be 7 centimeters. And you can just kind of see that I've given a bit of a little dash there to indicate that this is a regular hexagon. Okay. Now, in order to calculate the surface area of this, I need to break it up into some composite shapes. Okay. Because there is a way to calculate the surface area for this, but it's using some geometry rules that are a little bit tricky. Okay. So if you want to look up the geometry method, okay, you can do that. And I won't go through that in this video, but there's a geometry method to do that, okay? And I'll try to find a video to link that if that's something you want to look at. But another way to do it would be to break it up into composite shapes. So if I do something like this, then you can kind of see that I've broken it up into 2 triangles, which are going to be the same. So you could do triangle A, triangle A, and that would be another triangle A. And then you've got rectangle B, okay? Now you can see in order to figure this out, you need this length here, and we don't quite know that at this stage. The other thing we need to consider is to calculate the triangle, we need the base times the height. So we actually need both this measurement here and this measurement here that we need to calculate, okay? So that's going to be kind of tricky. So that's why I would recommend that when you're doing this, you actually have that length already completed, okay? So the best way to do that is just by thinking how many of your glue stick that you can fit in. So if this is my glue stick as my example, and I want to do, I want to fit in a certain number, okay? So I get that, and I say, okay, I'm going to go 1, 2, 3, 4 glue sticks. I'm going to fit in 4, okay? Now that doesn't really fit in 4, but let's just kind of pretend that worked. So we're going to go 4 glue sticks. I'll make it a little bit smaller the second time around. And I'm going to go 2 rows like this. Okay. I'll make it a bit smaller so it actually looks like it fits this time. 1, 2, 3, 3, 4. Now, if I have the diameter of each one of those glue sticks, okay, and you've already calculated this, then I could figure out exactly how long I'd want that hexagon to be, and then how high I want that hexagon to be. So let's say, for example, my diameter is 3. So I know that going along here, I'd have 3, 6, 9, 12. And I might want to give a little bit extra room, okay? Just because you don't want everything so tight that the packaging is not going to be able to hold the container in the first place. So that gives me 12. So I might want to go 12.5, for example, as my line going across. I might just do it down here. So 12.5. So that's how I'm kind of seeing what that's going to be. Now, the diameter going down is also going to be 3. And I'm going 2 glue sticks going down. So that would be 6 at its absolute tightest. So I might want to give it a bit more space once again. So maybe I'll say 6.5 or maybe 7. Now I'm going to go with 7 just because that's what I ended up doing initially. So let's say that's 7. is verified here. Okay. Now, if you want to stack more here, obviously you could do that. So you might want to just kind of visually figure out, how many more can I fit in here? Can I fit in another one here and another one here? Sorry. Okay, that kind of thing in order to get my total. All right. So long story short, I know that I might actually get rid of those. I know that I've got my 12.5 and I know that I've got my 7. Okay. So with the 7 and the 12.5, I can calculate the surface area of the rectangle. Okay. So that's just going to be the 12.5 times by the 7. That's easy. But now I need the triangle. Now for the triangle, I need the base and I need the height. So I still need this red line up here. I don't know that height yet. Okay. So how am I going to do that? I'm going to use Pythagoras. The other option is to draw a scale diagram. So what I mean by that is actually draw a rectangle, 12.57, 12.57, and then you would need to draw 2 7-centimeter sections here until they meet up. But the easier way to do it is probably using Pythagoras. So I'll just show you how to do that. So I've got my triangle here. So this is going to be that part there. Okay. And I'll write in my sides. So I've got a 7. I've got my x, which is what I'm trying to figure out. And I've got this base. Now, if the whole thing along here is 12.5, I would have half of 12.5 as my base. So that would be 6.25. Now, Pythagoras, the formula is c squared equals a squared plus b squared. Okay. Now, c is the hypotenuse of the right angle triangle. So in this instance, c would be over here. And then your a side and your b side, it doesn't matter which one's which. Okay. Now, because we're trying to find out the smaller side, I need to rearrange this Pythagoras equation in order to get a squared. So that's equal to c squared, take away b squared. So that's the rearrangement. Okay. And then we'll substitute. So we'll substitute our x and we'll substitute our c is 7 squared. Take away the 6.25 squared. So x is squared is equal to 7 7s are 49. And I'll need to figure out 6.25, whoops, 6.25 times 6.25, which is 39.06. We'll just round up. So x is going to be this, if I just do that in my head, it's going to be 9.94. So x is going to be the square root of 9.94. So 9.94 square root is 3.15. So x is equal to 3.15 centimeters. Okay. So that tells me that this height here is 3.15 centimeters. Okay. So that gives me information to complete that triangle. So now I know that the surface area of this big triangle here, this whole thing, is going to be half times base times height. So half times by the base, so the whole thing there, the base is 12.5. And the height is what we've just figured out, the 3.15. Okay. So I can use my non-rounded off version to be more accurate. 12.5 times 0.5, that gives me 19.70 centimeters squared. Okay. And because we've got 2 of those triangles of that A, we'll multiply that by 2 for the 2 triangles. Okay. And then we can add everything together. So the rectangle plus the 2 triangles to give us the surface area of the hexagon. Okay. Now, once we have that, so if we look at our net here, that's what we figured out. We times that by 2 to get this. And then we figure out the rectangle surface areas, which should be hopefully easy enough. That would be, this line here would be 7. And then this here would be the height, whatever the height of the container is. Okay. And you would figure that out. So that's that one there. You could figure that out based on how high your glue sticks are and whether you're stacking 1 or 2. You might stack 2 layers, so maybe the height is quite tall. And then you would multiply that by 1, 2, 3, 4, 5, 6 in order to get your total surface area. Now, to get your volume, it's going to be the surface area of 1 hexagon multiplied by the surface area of 1 rectangular height. So volume is this multiplied by this, and that's it. Okay. So that's pretty easy, hopefully. Hopefully. Now, if we keep going, and look at an octagon, so something quite similar, okay? Same concept as before. Try and make it a regular octagon by having a measurement that's the same for all of the sides. It'll just make it a lot easier, okay? And then to find out the surface area, you want to split this up as a composite shape. Now, this time, instead of triangles, you're going to have a trapezium. So you've got trapezium A and you've got rectangle B. Again, in order to do this well, you want to, or make it easy on yourself, not only do you want to have the sides kind of labeled out, you want to have this one here pre-measured. Now, how do you know what measurement to choose? Again, it's based on how many glue sticks you want to fit in there and the diameter of those glue sticks, okay? So if I make my glue sticks here, and again, I'll make them 3. Actually, I might change it up this time just to make the calculation a bit different. So I'm going to fit, let's just say I'll fit 3 of them this time, okay? So I'm deciding that I'm going to fit 3, and I'm going to go 3 again. Just ignore the fact that that doesn't actually fit in there. Let's just pretend that it does, okay? So let's say I want to do 3. And this time the diameter can still be 3, just to make it the same as before. Let's just say 3. So this time, how many am I fitting here? So I'm going 3, 6, 9. So let's make this one, let's just say 11. Okay, because 9, there's a bit of space there. Let's say 11. And then going down, you've got 1, 2. And that doesn't quite fit, okay? Now, I wouldn't do that in real life. I would, change it so it does fit. I'd make my shape bigger kind of thing, all right? So let's just pretend these do fit in there. So I'm going to make that 6, okay? Actually, 6.5. So all of the sides are 6.5 because it's a regular hexagon, okay? So to find the surface area of the rectangle, so this rectangular bit here, which I'll say is B, shape B, then that's easy. That's just length times width, which is 11 times 6.5, which is going to be 65, 71.5 centimeters squared. So now you've got the trapezium, which is going to be the harder part. Let me just draw a trapezium. No, I can't. So we've got a trapezium here, like that. Okay. Now that because we've done the measurements, it's not too bad. So we've got 6.5 up the top, and we've got 11.5 here. Okay. Now to find the surface area of a trapezium, you've got your A side and your B side, but you also need the height. Okay. Because the surface area of a trapezium equals A plus B over 2 times by height. So this is the thing that we don't have, this height here, okay? So this measurement here. How are we going to get that? So what we'll do is we'll do Pythagoras again. So we've got this line here that gives us a right angle triangle. All right. So if I bring that triangle down here, it's the wrong way around, but hopefully it kind of makes sense here. Now I know this one, that diagonal, that's my 6.5. Because again, it's a regular octagon, so all shapes and all sides are the same. And I can figure out this base here, this part here. Now, how can I do that? If this top is 6.5 and this bottom is 11, okay, not 11.5. I made a mistake down there. Whoops. The difference between those two, so 11 take away 6.5 is 4.5. Okay, so basically 4.5 is going to make up this plus this. Okay, that's the difference of the two. So I can do my 4.5 chopped in half divided by 2, which gives me 2.25. So that 2.25 is going to be my base here. All right. So now I know my two sides, and now I can get my height, which is what I need for my trapezium formula. So that's my x. So I'm going to do some Pythagoras again. Okay. So I've got my hypotenuse. I've got my a and b. So c squared equals a squared plus b squared. Rearrange that. A squared equals c squared. Take away b squared. So that's my unknown is equal to 6.5 squared. Just move myself up here. Take away 2.25 squared. So 6.5 times 6.5 is 42.25. Take away 2.25 times 2.25 is 5.06. Okay. Which is 42.25 take away 5.06 is 37.19. So x is equal to root 37.15, which is 6.09, round that up, 6.10. 6.10 centimeters, okay? So that height is, so this one here is 6.10 centimeters. So that's that there, okay? So 6.10. So if I insert that into my surface area for a trapezium, so A plus B would be 6.5 and 11. Divided by 2 times by 6.1. Okay. So if I do that in my calculator, 6.5 plus 11 divided by 2 times by 6.1 gives me 53.37. Round that up to 53.38. Okay. So 53.38 centimeters squared. Sorry, we're getting very sloppy here. So in order to calculate the surface area of the composite shape, the octagon, you've got one of these and then two of them. Okay, it's because there's 2a, so you'd have to multiply that by 2. Then you add it all together. All right, so 53 plus 71. So it'd be something around 100 and 177 or 178 centimeters squared. So hopefully in this video, I've kind of showed you the need to use Pythagoras in order to accurately calculate the surface area for an hexagon or your octagon. Hope that made sense. Hope you learned something. Appreciate your time. Thanks.